Hello everyone, today I want to talk about an interesting paper of quality control for 3D printing metal parts. The title is Large Surface Analysis of 3D printing metal using light and reflections. This main question is how can we quickly check if metal parts made by 3D printing have a good quality? The authors create a new method that is fast, cheap, and easy to use. Okay, but where is the problem? When we make metals parts using 3D printing, also called additive manufacturing, the surface tells a lot about the quality. Think of it like reading a history breathing on the surface. Traditional methods to check surface have big problems. They are very slow, they can only look at small areas, they are expensive, they don't work well on shiny metal surface. Imagine trying to check a 1 centimeter square surface. All metals could take 4 hours. This is too slow for factories. And now, what is the solution? The research create a metal colored directional reflectance microscopy, or DRM. This is idea simple but clever. Here how it works. They shine light on the metal surface from different angles, like moving a flashlight around an object. When they take photos from angle edge, the way light reflects tell them about the surface shape and roughness. Think about looking at a car in the sunlight. When you move around it, you see different reflections. This method does the same thing, but in a very controlled statistical way. They use a mathematical models called the Funk model to understand the reflection patterns. This model has been used in computer graphics for years, so it's well understood and reliable. But what is the result? The results are impressive. Their method can scan 1 centimeter square surface in just 1 hour. That's 4 times faster. Create 3D maps of the surface. Measure surface roughness at microscopic levels, work on a large areas, not just tiny spots. They test in a cobalt chrome metal sample made by 3D printing. The method choosibly identify wheel tracks, surface defects, and roughness patterns. When they compared the results with traditional methods, they found good agreement. The agreement difference was only about degrees when measuring surface angles. But what is the best part? They can reduce the measurement time even more by using fewer light angles. Only 12 instead of 468. But why this matter? This technology is important for several reasons. First, it can work during manufacturing, not just after. Imagine catching the fence while the part is still being built later by later. You could fix problem immediately. Second, the equipment is inexpensive. Just the light, a microscope, and a camera, no expensive laser system needed. Third, is fast enough for factory use. Time is money in manufacturing. And finally, it can help predict the part's quality with destroying the part. We call this not destroying this testing. In short, this paper presents a new method to check the quality of 3D printed metal parts that is quick, affordable, and reliable, as 3D printing growth in fields like aerospace and healthcare. Quality control techniques like this will be crucial. In the future, 3D printers might include light system and automatic check quality while printing each layer. Uh, this could make 3D printed parts safer and more dependable. Uh, Thank you for watching. I hope this was helpful and easy to understand.